like this that he proposed. And for that mission, the key performance parameters was also explicitly mentioned and discussed. A full technical description was given with link budgets, power, mass budgets. The orbit design for the constellation was done. And again, the implementation plan and the project schedule was complete. So it was a well thought through mission. Again, in that case, maybe it was also something that he planned before he knew about this competition, and he had some advantage working in the space industry, etc. So if we want to give newcomers an opportunity also to be in the final, amongst the finalists, maybe we should change some of the rules for the competition. Because definitely the guys that won or came first, second and third is people that work in the space industry and they know what they do. The third one, that one from MIT, was done by students, but again, they had all of them. Okay, this was the second one, the exoplanet constellation. Oh, this is the one from MIT. That was second, sorry. The third one is the one I discussed second. Okay, so this was one done by students from MIT working in space engineering. And you could also see from the paper, technically they know what they were doing. That is what they worked on for their PhDs, for example. And it was also maybe a very challenging mission for small satellites. But at the end, they convinced the reviewers that it is doable. It will be difficult, it will be challenging, but it will be doable. It's not impossible to do it. So I think if you go back to your countries and you want to encourage students or groups to enroll for the next competition, stress that they have to present something that is technically feasible. Not only a good idea, it must be technically feasible. And if they don't have the knowledge themselves, ask them to go and seek information from somewhere, from people that knows satellite engineering and the principles of satellite engineering. So this mission, as I've said, was a very challenging mission from a technical point of view. And maybe it's a tall order to implement this mission on 15-kilogram satellites, but they convinced us that they've looked at all the hurdles and the difficulties, and they think it's possible. And without doing it, really, it's not for us to say it's impossible, you cannot do it. So the third prize went to this distributed multispectral imaging system proposed by one person that worked in the space industry. Ray, I don't know whether there's anything more I can say. I can also... Okay, this is the new evaluation criteria. Again, you can see that for category 1, that's the category I have to talk about. Originality is 50 marks and feasibility 50 marks. So on the originality side, you must make sure it's a novel mission. It will have an impact on society, so 50% of the marks or 25% of the marks will go to impact on society and 25% on the novelty of the mission. And it's no use just satisfy this first set of criteria. The next part is as important. Also 50% of the marks is the technical feasibility of the mission. And to demonstrate that you've looked at all the aspects from a technical point of view, 20 marks there, from a programmatic point of view, 15 marks, and from an operational point of view. Don't only look at the space segment, but also look at the support segment after the launch of the satellite, how you're going to support your mission on in your ground components. Okay, is there any questions? I don't have much more to say, unless you can ask me something that I haven't really presented at this stage. And so Martin, if you have anything to add, feel free to do so. Please ask if you want to know what's going on inside the head of the reviewers. Yes, Willie.
Thank you. Good morning, everyone. I was thinking, according to what you said, that the satellite must be less than 50 kilograms mass.
The next competition, yes, the second one. The 15 was the first competition.
Okay. We will keep the third place, this category for multispectral imaging. So I am trying to imagine how we can develop a device of 15 kilograms that has the capability to take images of the Earth in a very short distance. I'm thinking about the focus of the sensors, the distance of the focus. So, do you think that the 15 kilograms could be enough for this category of multispectral imaging?
For the first competition, or now for the second competition?
For the next competition.
For the next competition, the limit is 50 kilograms.
Oh, 50.
50. It was 15 for the first competition.
Oh, okay.
So it becomes more feasible to have higher resolution with 50 kilograms because you can have a larger telescope.
Yes.
So not only the focal length that's important, but also the aperture of the telescope.
Yeah.
To give you the resolution that you require, because there's a diffraction limit that you have to look at. Not only a pixel resolution and a focal length. And that always limits your resolution from a 50 kilogram satellite, I would say, to not much better than 5 or 6 meters per pixel. You have to do some special tricks to get a higher resolution from a 50 kilogram satellite. Maybe folded optics, but your aperture must be large enough for a better resolution than 5 meters per pixel. So you need to look at that and understand that's important.
Yes. Yeah. Yes. Okay. That solves my inquiry, because I was thinking 15 kilograms, so it's very small. So
no, 15 kilograms. 15. You will be. If you can do 15 meters per pixel or 10 meters per pixel, that's about the limit that you can do from 15 kilograms. Unless you have folded optics, like the PRISM mission of the University of Tokyo. Then you can deploy the optics and you have a large aperture as well to give you a higher resolution.
Okay.
So you have to come up with novel, new optical ideas to do it that way.
Yes, yes. Okay, thank you.
Good morning, everybody. Thank you for your clarification. I have a little bit different question. As you presented that basically the first 3 ideas, people working in a well-established company in space engineering as well as institute also, academia, have a long history of working in space. So this is a little bit, a little bit disencouraging for regions that have newcomers to space engineering. And I'm thinking about how to motivate the young, enthusiastic people.
Yeah, so I agree with you. I've also mentioned it. So one can, because you don't want to demotivate young comers to the competition, but you also don't want to demotivate experienced people to present their ideas that can be feasible and can be good ideas as well. So I think maybe for future is to implement also a newcomers competition, or make a special prize just for the newcomers, the best newcomer idea. Because as you said, if you look at the criteria, the guys that's experienced in space will always win, because they have all the knowledge and they know how to do it. It's not to say that the newcomer cannot come up with an extremely novel idea that no one else has thought of before, but it's less likely. That it's more likely that the guys that work in space environment, will be the people that are the strongest proposals. So there's many ways to do it. Maybe in your marking scheme also to have a 20-point mark for newcomers, but it's difficult to judge, because how will you judge that newcomer that didn't have a lot of help from a person that's experienced? He can present it as his idea, but he had a lot of input from experienced a group of people. So it's a difficult thing. Maybe we can think of it, of how to handle that problem for the next competition, perhaps. But to have a newcomers prize, I think it's a good idea also to motivate newcomers to this. But that's for the organizers to really implement.
Yeah, well, actually, I want to add